using the definition that f of g of x is going to equal x if f and g are inverses, we're going to verify f of x equals 1/3 x plus 2 and g of x equals 3x minus 6 are inverses of one another. So first I'm going to find f of g of x. So I'm going to rewrite the f function. So I'm going to do that in blue. Here's the f function right here. It's 1/3 x plus 2. And the g of x is going to be the red function. So everywhere I see an x in the f function, I'm going to put the expression 3x minus 6 in its place. So now I'm putting in g of x into the function f. And I'm going to simplify. So I'm going to distribute. I get x minus 2, and then plus 2 on the outside, and x minus 2 plus 2 is x. Therefore, f and g are inverses. However, what if we would have gone the opposite way? What if we would have said g of f of x? Can I do that? Well, sure we can, because if they're inverses of one another, it doesn't matter which you put into the other. You should and you will get x as a result when putting one inverse into the other. So I'm going to start with 3x minus 6, and in place of x I put parentheses, and in place of x I'm going to put f of x. So I'm going to put 1/3 x plus 2. Now I'm going to distribute. 3 times 1/3 x is x, plus 6 minus 6 is x. F and g are inverses. So no matter which composition you would have chosen to do, either way, those two functions are inverses of one another. So here's one for you to try. Are the following functions inverses of one another? So I encourage you to take the time right now and try it. Try it on your own and see what you get. When you're ready to look at the results, go ahead and press play. So I'm going to find if f of g of x is equal to x. So I'm going to, my f of x is going to be in blue, my g of x, I'll make that in red. So I'm going to start with f of x, 2 times the quantity plus 1, and in that quantity I'm going to put the g function. And as soon as I do that, I get x minus 2 plus 1. X minus 2 is x minus 1. That is not x. Therefore, these are not inverses of one another. Now, there's really no need to go on. However, what if you would have done it the opposite way? So let's just show our work there. If you would have put g of f of x in, you would have started with 1/2, and then you would have had parentheses minus 1, and then you would have put 2x plus 1 in the parentheses, and you would have distributed, getting x plus 1/2 minus 1, which is x minus 1/2, which is not x. Therefore, if you would have done it g of f of x, if you would have computed that composition, you still would have gotten the fact that they are not inverses of one another. Now, suppose f and g are inverses and f of 2 is equal to 3. What is g of 3? Well, f of 2 is equal to 3. So I'm going to draw a little table. Here's the f function. Okay. I put a 2 in and I get a 3 out. If f and g are inverses, then when I put a 3 in, I'm going to get a 2 out. So g of 3 is equal to 2. So you can use tables. You can also use ordered pairs. 2, 3 is going to become 3, 2 for the inverse. In the next video, we're going to talk about inverse notation. So when we have to label a function's inverse, how do we do that and how do we pronounce it? And ultimately, how do we compute it? How do we determine what an inverse is? How do we find it?